So next function, we have y equals x plus 1 over x minus 3 times x plus 2. So using the information we gathered a while ago, x-intercept negative 1, 0, y-intercept 0, negative 1 over 6, horizontal asymptote y equals 0, and the two vertical asymptote, which is x equals 3 and x equals negative 2. So a rational function has three expressions, x plus 1, x minus 3, and x plus 2. So we have three critical values, x equals negative 1, x equals 3, and x equals negative 2. So we have four regions in our interval. So the intervals are x less than negative 2, x between negative 2 and negative 1, x between negative 1 and 3, and x is greater than 3. And the expressions that I said a while ago, x plus 1, x minus 3, x plus 1, and the rational expression, x plus 1 over x minus 3 times x plus 2. The test points, we have x equals negative 3, x equals negative 1.5, x equals 0, and x equals 4. Then let us test the points. So first we have x equals negative 3. So negative 3 plus 1, negative 2, negative. Negative 1.5 plus 1, negative 0.5, negative. 0 plus 1, 1, positive 1, positive. 4 plus 1, 5, so positive. Negative 3 minus negative 3, negative 6, negative. Negative 1.5 minus 3, negative 4.5, negative. 0 minus 3, negative 3, so negative again. And 4 minus 3, 1, so positive. Now the third expression, negative 3 plus 2, negative 1, negative. Negative 1.5 plus 2, negative 0.5. Positive 0.5, rather, so positive. 0 plus 2, 2, positive. And lastly, 4 plus 2, 6, positive. Then multiply the signs. So negative times negative, positive times negative, negative. Negative times negative, positive times positive, positive. Positive times negative, negative. Negative times positive, negative. And lastly, 3 positive, positive. Okay, so therefore, the region less than negative 2 is negative, so it is below the x-axis. The region between negative 2 and negative 1 is positive, so above the x-axis. The region between negative 1 and 3, below the x-axis. And lastly, below the region above 3, or the x value above 3 is positive, so above the x-axis. So we have the graph, okay? The two asymptotes, so vertical asymptote negative 2, negative 3, and the horizontal asymptote of 0. The intercepts and the graph, okay? So we have this graph, okay? So next one, the domain and the range. So first one, the domain. So the domain is x is an element of real number such that x is not equal to negative 2 and 3, since we have two vertical asymptotes. And the range is y is equal to element of real number, or y is an element of real number such that y is not equal to 0, which is the horizontal asymptote. Okay? And last one, we have y equals 4x over x squared minus 25. So we have the intercept 0, 0, 0, 0, y equals 0 for the horizontal asymptote, vertical asymptote negative 5 and 5. So we will expand this, so we have x plus 5 times x minus 5. So we have three expressions, so 4x, x plus 5, and x minus 5. So three critical values, negative 5, 0, and 5. So we have four regions. So x is less than negative 5, x between negative 5 and 0, x between 0 and 5, and x is greater than 5. So we have the expressions for x, x minus 5, x plus 5, then the rational expression. Then the test points. These points are located in each region. So x equals negative 6, x equals negative 1, x equals 1, and x equals 6. Then test the point. So we have the signs. Then multiply. So negative, negative, negative. So we have negative. So below x-axis. So negative, negative times positive is positive. Above x-axis, then positive, negative times positive is negative. So below x-axis. And lastly, 3 positives. So we have above the x-axis. So we can see here, so x is less than negative 5, so negative 5. So we have below the x-axis. Then between negative 5 and 0, so negative 5 and 0, so we have above the x-axis, so above. Then the intercepts, then between 0 and 5, so 0 and 5, so below x-axis. So the graph is below x-axis. Then you will reflect this one into this. Okay? So x is greater than 5, so 5 greater than above x-axis. So this is the graph. So therefore, it is the graph of y equals 4x over x squared minus 25. So the domain, so x is an element of real number such that x is not equal to positive negative 5. So positive negative 5. And the range is y is an element of real numbers. Since a while ago I said that the horizontal asymptote is y equals 0, but we have intercepts of 0, 0. Therefore, the graph will pass at the origin. So we will ignore the horizontal asymptote. So next one, we will graph rational function step by step. Okay? So first one is determine the intercept of the rational function. For example, we have here y equals x squared minus x minus 20 over x squared minus 16. So we will simplify. So x minus 5 times x plus 4 over x minus 4 times x plus 4. So we will cancel x plus 4. So therefore, we have the new rational function y equals x minus 5 over x minus 4. So therefore, the x-intercept is 5, 0. So replace y to 0. So 0 times x minus 4, 0. So 0 equals x minus 5. So x equals 5, so 5 and 0. And y-intercept is change x to 0. So negative 5 over negative 4, so 0 and 5 over 4. So next one, determine the asymptote of the rational function. So first is the horizontal asymptote. So we have the simplified rational function. So since we have the degree of the numerator 1 and the denominator 1 also, so we will divide the coefficients. 1 divided 1 is 1, so y equals 1. So the horizontal asymptote is 1. So next one, the vertical asymptote. So we have the value that makes the denominator 0. So x minus 4. So the value that makes the denominator 0 is 4. So we have the horizontal asymptote 1 and the vertical asymptote of 4. So next one is determine the whole of the rational function. So in determining the whole of the rational function, first we need to simplify the rational function. So we did it a while ago. So y equals x minus 5 times x plus 4 over x minus 4 times x plus 4. So the whole is defined or determined by the same expression in the numerator and the denominator. So in this case, we have x plus 4. Okay? So we will equate x plus 4 to 0. So x plus 4, since x plus 4 is common to both numerator and denominator, if we substitute the value of x to that x plus 4, so we will be having 0 over 0. So the whole will make the function indeterminate. So therefore, we will need to define or to know the whole in order for us to make it in the graph or to emphasize it in the graph. So in this case, we have the whole of x is equal to negative 4. So it says that negative 4 makes the function indeterminate. Okay, so the whole is in negative 4. So since whole is at x equal to negative 4, then we need to find its coordinate. Okay, so negative 4, substitute to the new rational function. So negative 4, substitute, we have y equals 9 over 8. So therefore, the coordinates of the whole is negative 4, comma, 9 over 8. Okay? And next one, determine the domain and range of the rational. So a while ago, we can say that the domain and range is found or can be easily constructed with the use of the asymptotes. Okay? So, since the horizontal asymptote is y equals 1 and the vertical asymptote is x equals 4, therefore, the domain is x is an element of real number such that x is not equal to positive or negative 4. Okay? Since regardless of the sign of 4, if it is squared, it will produce 16. So 16 minus 16 is 0. So therefore, the denominator becomes 0. So it is still acceptable. Okay? So next one is the range. So the range is y is an element of real number such that y is not equal to 1 and 9 over 8. Okay? Since 9 over 8 is the location of the whole and the whole is not included to the range. Okay? So the same as the domain. So originally 4 and negative 4, the coordinate of the whole. Okay? So now let's graph the function. So we have the informations, and before we graph, we will construct a sign table. So since it is reduced to y equals x minus 5 over x minus 4, so we have two critical values, x equals 5 and 4. So we have three regions, x is less than 4, x between 4 and 5, and x greater than 5. So the expression x minus 5, x minus 4, and the test points. So the test points are 3, 4.5, and 6. So we will test them. So the signs are negative, negative, positive, negative, positive, positive, then multiply. So we have positive above x-axis, negative below x-axis, and positive above x-axis. So we will graph. So we have the asymptote. Asymptote is 1 and 4. This one. Then the intercepts. So 0 and 5 over 4 and 5, 0. Okay? So the whole is this one. Okay? So this is the graph of the rational function x squared minus x minus 20 over x squared minus 16.